Okay, so it's Sunday, and yesterday I had both my new COVID booster and a flu shot at the same time. So I'm feeling pretty awful today, but nevertheless, I want to show you this Spaceship engine implementation. I just used the same I just did it in a template. I didn't bother opening up our full project. This is directly applicable to what we have been doing in class with our Spaceship engine. So first of all, I'll let you hear what I have. I just started with a few basic assets of different airplane engines. I've got a low, a medium, and a high. I processed them minimally. I didn't really work so hard on making these fabulous because it was mainly the implementation that I think we needed to talk about more than anything. So these are the waves, and remember we open them up and make sure that looping is set to true on all of them. And all three of these are inside of this engine sound cue, okay? So there are 3 wave players, and I have to check looping on all 3 of them, and each one of those are just the waves that we saw before in the content drawer. So if I hit play node, you'll just hear the 3 loops. And you can hear also that I didn't necessarily kill myself trying to make them sound too similar. That's okay. First, let's hear it in the game, and then I will elaborate on what else is going on inside the sound cue. Ooh! Didn't mean to almost crash. Notice though that it's smooth across the entire range of floats, and the craft defaults to 500 units per second, I think. But I also coded an all stop, which will take it all the way down to 0. Okay? Furthermore, if we accelerate all the way, we can see that it tops out at 4,000. And we'll stop once again. Smooth across the entire range. Eventually that will silence itself. Okay, so let's go back down. Let's actually get out of there and elaborate on what I'm doing inside the sound cue. Okay, so what I decided is, after trying a few things, is that when I was setting up these continuous modulators, I was noticing that the ranges that I was setting caused the different layers to seem to accelerate at different rates. So the strategy that I employed is to allow each of the continuous modulators to accommodate the entire range of input floats. That way I knew that they would all change pitch at a consistent rate. And then for each one, with the exception of the first one, a little bit different. The first one, the minimum output I set to 1. The reason that I did that is because I didn't want it to start at a pitch that was lower than the default pitch. Okay, so the default pitch is 1. You can hear the way that that sounds in the game. Again, let me just play the game. That's the default pitch, and that's not shifted from when I created it. But if I were to go inside the sound cue and set the minimum output pitch to something lower than the default pitch, let's say 0, because we know the range can start from 0. It could even start from a range, I think, less than 0, but we'll just set it to 0 for now. We'll save that, and I'll hit play, and you can hear it's starting much lower, and I didn't want it to. The system still works, but I didn't want it to start at a lower pitch than that base layer. So I set the minimum output to 1 also, just for that one continuous modulator, and then 2 is an octave higher. So over the entire range of floats, that can increase in pitch by an octave, and I can tweak that still. The other continuous modulators I didn't bother because they're usually fading in as the previous one is fading out. So I allowed them to start at a lower pitch than their default, because usually by the time I can hear them during the fade, they're at least at their default pitch or higher. Okay, and I did that for both of these. I also set the parameter mode to absolute for each one. And you'll notice that in the code, if we go back to Flying Blueprint, in our space buggy, it's here. So in the blueprint that comes with the template, in fact, set forward speed value using thrust input. Okay, so here's the input axis thrust, and I just followed that to the end where it's setting the variable. And that luckily we have that variable already prepared for us, current forward speed. So after that, after it's being set, I did a print string. That's how we got the values on the left side of the screen. And I just dragged the current forward speed. It looks like I even have another one in here that I don't need, but I just dragged it from the graph, grabbed it from the variables tab and into the graph. And once I have that, I can convert it to absolute float, and that provided the input value for my print string, but it's also the infloat for the set float parameter, who's got a target name of pitch, not a target name, a parameter name of pitch. Remember, when we're parameterizing things in sound cues, such as the pitch in a continuous modulator or the crossfades in a crossfade by parameter, we need to call it something that we can duplicate here in the set float parameter node inside of a blueprint. So I'm just directly using the current forward speed to determine the behavior, the infloats, where they're needed for all three continuous modulators and the crossfade by parameter node. There is another way we can understand this better. If I disconnect these two continuous modulators and just listen to the first one, let's save that. Let's also compile and save our pawn for now. And you'll hear just the first layer's behavior, and then that will only work up to a certain speed. So let's try it. I'll accelerate. You'll hear it fade in. Actually, I'll start from 0. And I'll start to accelerate. You'll hear it fade in, and the pitch will go up, and then it will start fading out at a certain point. And that's where other layers would start to take over. So let's do that again inside the cue. Let's listen to the middle layer and not the first layer. We'll save the cue that way and play the game. Now we have no sound, even if I start from 0. And I'll start to accelerate, and you'll hear the middle layer come in at some point. We're above 500. Okay, so that's coming in, seems like around 1200 or so. But it's also fading out before we reach our maximum speed to allow the next layer to take over. And then that'll fade out before it reaches 0 again. And lastly, if we wanted to listen to this layer alone, we could disconnect that one, save the cue, and play the game again. And now we'll have no sound. Let's go to 0. Let's break. And that won't come in until we're going at a pretty good clip. So let's listen for it. And it'll fade out. And we're still decelerating. Okay, so we'd be passing through those other two layers on the way down at this point. Okay, so now if we hook them all back up again, let's talk about the crossfade values. And again, this usually has to be done by estimation, but I wanted them to overlap by quite a bit. So for our first layer, that is accepting the infloat range from 0 through 1000. And then by the time it reaches 1000, it should be fully faded in. Then at an infloat of 1200, that's where it begins to fade out and is completely faded out by an input float of 2500. Although the next layer, that is the middle layer, okay, starts to fade in at 1000. And notice that this one is starting to fade out at 1200. So this is fading in before this one starts to fade out by a small amount and is completely faded out by, let's see, I should be in the crossfade, excuse me. Crossfade by parameter. Yeah, it's called pitch. I really, it's confusing here because I just used the same parameter name, but it's really, we're crossfading the volume. I hope that is clear. It's the continuous modulators that are doing the pitch. I should have found a better name for the parameters, something like engine power or something like that. But in any case, once again, this one starts to fade in at an input float of 1000 and is faded in completely by 2500. And then as the infloat increases to 3000, that's where it starts to fade out and is completely faded out by 3500. The last layer starts to fade in at a value of 2000. Okay, so that is at a value that precedes, it's before this one starts fading out, this one starts fading in, and is completely faded in by the time we reach 4000. The pitch values for the end, not the pitch, but the infloat values, I should say, for the end. It's not really pitch at this point, it's volume. That's what the crossfader does. I just set to numbers that are higher than it will ever reach, so it's going to be capped at 4000. Okay? So what else? Each continuous modulator, the parameter mode is set to absolute. I think I may have mentioned that because once I got the current forward speed, which is a float, I just made sure it was always going to be an absolute positive value. That fed my print string and also provided the infloat for our set float parameter node for our engine Q. And the engine Q is what we've been working with here. So let's save that. And the way that I got a reference to it inside of the blueprint is simply by making it an audio component. If you have a sound cue that you want to make an audio component, just drag it over the tab and hover over your components, your components view right here. You can see I'm not going to let go because I already have one in there. Okay, this is the same cue, and I did it the same way. So I just dragged it and dropped it. Now let me not do that and go back into the blueprint. So here it is as an audio component, and I did a couple of things in the details panel. This doesn't matter that much. I disabled allow spatialization because I wanted it to be a 2D sound. I could always turn that back on. It's basically right with us, so it shouldn't make very much of a difference anyway. What else did I do is I made sure, although this was on by default, I just double checked that auto activate was active. That way I don't have to call a play function. So now, okay, when this is at 0, we hear nothing. This is why that sound cue should have a base layer of just general cockpit idling, or operation, internal power source, something pulsating, internal beeps and stuff like that, to keep it interesting for when we're not accelerating. I haven't done that here, but that would combine very effectively with an engine sound such as this. So please do that. spend some time creating a base layer as well as the engine acceleration. And once again, this is the code. By the way, I was able to set preset thrust for this just by prototyping it with keyboard 1. Remember, the pawn defaults to a cruising speed of 500, and in your project, you should have 4 levels of thrust and manual control with your spacebar, as I recall. That's just fine. That's not going to interfere with the sound cue behaving just as we've programmed it to behave. So hopefully this gives you a better understanding of that. And in the little teaser video, I made what was called a HUD element, a heads-up display element. Not this video, but the teaser that I posted a couple of days ago on Canvas. And I would imagine that some of you are curious about that. And if you are, I will show you how to do that this Wednesday. If you want to make like a thruster level or meter or something along those lines, I'm happy to do that for you. But we can fly around a little bit more, and that'll be the video for today. And that would blend nicely into just a general cockpit ambience layer. Okay, so this is basically a 17-minute video. Thank you for being here, and we'll pick it up from where we left off on Wednesday. Thanks all. Have a good day. Bye.